All right, so we're doing chapter 1.5. We're going to start with question 5. Question 5 says we have to find the solution in vector form, I'm pretty sure. So we have 2x1 plus 2x2 plus 4x3 equals 0. Then we have negative 4x1 minus 4x2 minus 8x3, 0. Then we have negative 3x2 minus 3x3 equals 0. So obviously when we have a question like this, we have to put it into a matrix. 2, 2, 4. And then this right-hand side is just going to be equal to 0, because it's always just equal to 0. So we don't have to do much there in that regard. Negative 4, negative 4, negative 8. 0, negative 3, negative 3. So what we want to do is we want to get this into what's called reduced row echelon form, or RREF for short. And what that basically means is we're going to do our traditional row reduction, but instead we want ones as the start of all the pivot columns. So we want something like this. We want 1, and then whatever comes after is whatever comes after. But we want those ones to be the pivot columns. So looking at our matrix, we can see right away what we can do is we can always divide rows no matter what to make it simpler. So what we can do is we can actually divide row 1 by 2. We make it 1, 1, 2. We can divide row 2 by 2. Or actually we can divide row 2 by 4. Negative 4 actually. If we divide row 2 by negative 4, we get 1, 1, 2. And then we divide row 3 by negative 3. We get 0, 1, 1. So the reason we do that is because, like, look at this. It's so much simpler now. Now that we have the matrix in 1s and 2s instead of these big numbers right here, it's a lot simpler, and I think we can do a lot more in terms of finding out what we want. So we see that we have 2 of the same rows. And what we can do is if we take row 2 equals row 2 minus row 1, we get 1, 1, 2, 0, 0, 0, and 0, 1, 1. So what we have here is we have a row full of zeros. And so what that basically means is that's what we call a free variable. That's a free variable right there. That essentially means it can be any non-zero value. So this says x2 is equal to whatever. Reality can be whatever we want. We could set it equal to 1. We could set it equal to 2. We could set it equal to 3,000. Doesn't matter. So now what we have here is we have a free variable, and we want to make this just a little more simple. What we're going to do is we're going to say row 3 equals row 1 minus row 3. And so there we get 1, 1, 2, 0 minus 0, 1, 1, 0. So we get 1, 0, 1, 0. And so we get 1, 1, 2, 0, 0, 0, 0, 0, 1, 0, 1, 0. And so what I like to do whenever I have a free variable, I like to swap whatever it is to make it row 3. I like having row 3 be my free variable. So, given the laws of matrix row reduction, we can just swap it so that this is what we have. And then last but not least, what we're going to do is we're going to do row 1 equals row 1 minus row 2. So what we're going to get is 1, 1, 2, 0 minus 1, 0, 1, 0, 0, 0, 1, 1. So we have 0, 1, 1, 0, 0, hang on, messed up, 1, 0, 1, 0, and 0, 0, 0, 0. So now we have this, and look at this. We have reduced row echelon form because our matrix is essentially just ones and zeros, and that's kind of what you want when you have a problem like this. Reduced row echelon form is really nice when you can get it. Obviously, we see that the beginning of all the pivot columns are ones, so that's definitely very good. Now what we can do is we can start finding out our variables. So we know x3 is equal to a free variable. When we have x2, we have x1 minus x3 is equal to 0. Now, since we have x3 as our free variable, we want everything in terms of x3. Right? So we have x1 minus x3. So what we can do is we can subtract x1. So we get negative x3 is equal to negative x1. I made a little bit of a mistake here, actually. My fault. I made a little bit of a mistake. So I have x1 plus x3. That's my bad. x1 plus x3 equals 0. Wait. Give me one sec. All right, hang on. Back on track. We have x3 is free. Let's do the first row. We'll start off with this row right here. x2 plus x3 equals 0. So what we can do is we have in terms of x3, we need terms of x2, and then we need x1 as well. So we get x2 is equal to negative x3. We have that right there. And then now we need x1. x1 plus x3 is equal to 0. And then we get x3 is equal to negative x1. Or x1 is equal to negative x3. Once we have that, we have x3 is equal to free. x2 is equal to negative x3. And then x1 is equal to negative x3. So how we're going to write our answer is like this. Negative 1, negative 1, 1 times x3. And this is going to be our final answer. This is what they're looking for. So the reason we do that is because x3 is a free variable, right? x3 is a free variable. So it can be whatever we want. So let's say x3 is equal to 1. x2 is equal to negative x3. x2 is equal to negative 1. And then x1 is equal to negative x3. So x1 is equal to negative 1. Negative 1, negative 1, 1. And that's our answer. So this is our answer for that question. Let's move on to the next one. Inconsistent. So what we want to do is we want to check to see which columns have a pivot column. If there's no pivot in the column, it's going to be a free variable. So we can see in column 1, there's a pivot right here. In column 2, there's no pivot, so it's going to be free. In column 3, there's no pivot, so it's going to be free. In column 4, there is a pivot right here. Column 5, there's no pivot, so it's going to be free. In column 6, it's going to be a pivot. So we know that x2, x3, and x5 are free. So, okay, I messed up a little bit here. I thought that it was an augmented matrix. I was wrong. Anyways, we'll continue this. So we're going to pretend that this is all, this is all equal to 0. So we can find that out right now. We can see that x6 is going to be equal to 0. So that's something we know. We see right here, x4 plus 4x5 minus 6x6 is equal to 0. But we stated that x6 is just 0. So this is going to be equal to 0. So we have x4 is equal to negative 4x5. So we have that. And then we have the big one. This is the big one right here. x1 minus 2x2 plus 3x3 minus 6x4 plus 5x5 is equal to 0. But we stated we know what x6 is. There's no x6 here. We have x4 right here, so that's negative 4x5. So we have x1 minus 2x2 plus 3x3. We have so we said x4 is equal to 4x5. Negative 6 times 4, that's 24. So we have 24x5 plus 5x5. Yeah, my bad. I made a little bit of a mistake there. x1 minus 2x2 plus 3x3 plus 25 or 29x5. Erase that real quick. So we want to get this in terms of x1 because x2, x3, x5 are free. So we want to get this in terms of x1. So x1 is equal to 2x2 minus 3x3 minus 29x5 because we got them all on one side. So this is what we're going to get. So now what we're going to do is we're going to develop our final solution. And what we're going to do is we're going to set up a big matrix right here. So we have x1, x2, x3, x4, x5, x6. This is equal to, and we have to write down what we got for all of our values. So x1 is equal to 2x2 minus 3x3 minus, let me erase this real quick, 29x5. x2 is free, so that's just equal to x2. x3 is free, so that's just equal to x3. x4 is equal to negative 4x5. x5 is equal to x5, it's free. And then x6 is equal to 0. So this is what we have here. Now, to get this in parametric vector form, we're going to take all of our free variables and write them down here. So we have x2 plus x3 plus x5. So now what we have to do is we have to go through each of the terms and look for x2s, x3s, and x5s in our answer. So when we're looking at x1, we have 2x2, so that's a 2 right here. Negative 3x3, so it's a negative 3 right here. And then negative 29x5. So that's going to go right there. x2, we just have x2, so that's going to be 1. There's no x3s and no x5s in our x2s, so that's going to be zeros. x3 is equal to x3, so there was no x2s. 1 x3, no x5s. x4 is equal to negative 4x5. So that means there's going to be 0 here, 0 here, and negative 4. x5 is equal to x5, so there's going to be no x2s, no x3s, 1 x5. And x6 is equal to 0, so there's nothing here. And then this is our answer in parametric vector form. This is our answer. So whenever it asks you for parametric vector form, this is what you want to do. Whatever you have in your free variables, that's how many slots you're going to have here. So we have 3 free variables, 3 slots, all in terms of x2, x3, x5. Whatever you have here, you want to get them in terms of your free variables. So that's how you do question 12. I'm going to leave you to do question 10 because that you can use the skills that I just applied here and do question 10. So now we're going to look at the final question, which is, I believe, question 14. This one asks to describe the two solutions. So we have these two right here. I'm going to label this as A and I'm going to label this as B. Let's start with A right here. So we're going to put these in parametric vector form. So that means what we want to do before. What we want to do is we want to get everything in terms of x1. So this is going to be x1 equals. x1 is going to equal 2x2 minus 3x3. For this one down here, we're going to do the same thing. x1 is equal to 2x2 minus 3x3. But we have this 4 right here, so we have to be sure to add that 4. It's very important. It's very, very, very important. So what we're going to do here is we're going to do the same thing we did before. We're going to set up our columns. We're going to set them equal to what we got for our equation before. So x1 is equal to 2x2 minus 3x3. We only have in terms of x1, so that means x2 and x3 are free. So we know to put x2 and x3. Whenever we have a free variable, it's just going to be copied over. x1 is equal to 2x2 minus 3x3. So we're going to set this up. So remember what I said before. How many free variables we have are how many columns we're going to use. So right here we can see x1 is equal to 2x2 minus 3x3. So we have 2, negative 3. x2 is equal to x2, that's 1 and 0. And then x3 is equal to x3, that's 0 and 1 here. So this is the solution set for part A. For part B right here, we have x is equal to the same thing. We have 2x2 minus 3x3 plus 4. And then, like I said, x2 and x3 are free because they don't depend on anything. The only thing that depends on something else is x1. So we have x2 and x3. And so we're going to do the same thing we did before. How many free variables is how many columns we have. x1 is equal to 2x2 minus 3x3. And then we have this plus 4 right here. So what we're going to do is we're going to add another thing. We're going to add another vector. And then it's going to be 4 right here. Whenever we have that, that's what we call a point value. So whenever we have a point value, we want to add one more. And that's going to be what's filled with our point values. x2 is equal to x2, so that's 1, and 0 because there's no x3s. x3 is equal to x3, so that's 0 here because there's no x2s, and 1 here. And there's no 4s in these columns, so it's just going to be 4, 0, 0. And so those are the two solutions. And then it asks you to describe the two solutions. So what you want to do there is you want to say the solutions are mostly similar. Minus the plane in solution set B. And that's going to be the answer to that one. So let me know if this video helped. If you have any questions, let me know. I'll be free to answer any of them. Thanks. See you guys.